70-740 Lesson 7, Installing and Configuring Hyper-V. This will be the first of our lessons where we discuss Hyper-V and the virtualization tools that we can use to control it. We're going to be looking at how we go about installing and configuring Hyper-V, some different other concepts such as what the VM bus is, a virtual machine monitor, PowerShell Direct. There's a lot of different terminologies that we'll be approaching in this and that we should come away with a deeper understanding of. So what is virtualization? Virtualization is a way to take a physical system and create virtual connections and run it in a virtual environment. Instead of having a physical hard drive, we create a file that is a virtual hard disk file. It emulates a hard drive. Our host computer for our virtualization platform creates all the extensions to virtualize the CPU and memory and the network, and we can virtualize switches. All the ways that a normal physical computer would connect, so can our virtual machines. Using virtualization, we can take a single machine and allow it to run multiple instances of a server or desktop operating system. That host machine is what we call a hypervisor. It sits between the physical hardware and the operating system, and it is the main component that manages the virtual computers. Hyper-V is a hardware virtualization server role that enables you to create and manage these VMs, the virtual machines. By using hardware virtualization, we can subdivide that single physical computer into many virtual computers. Now, just like a physical computer, the virtual machine is going to have virtual processors, virtual memory, virtual disks, access to virtual switches, and an operating system that's going to run independently and be isolated from the host that it operates on. Also be aware that virtual machines need to be protected just like a physical machine. We would want to install our security software, our antivirus, firewalls, whatever protection methods you would normally put in place for your physical systems need to be done for your virtual systems as well. We can create a virtual lab environment, which is what we're doing for our course, to test applications, test compatibility, test out new operating system patches, new service packs, upgrades before we apply them to our production machines. So not only can we run production computers in a virtualized environment, we can also create lab environments where we can test out things before we apply them to the production. We can use it to run applications written for older versions of Windows. Now, our server virtualization in Windows Server 2016, it's based on a module called a hypervisor. This is also sometimes called a virtual machine monitor, the VMM. It's responsible for doing what we call abstracting the physical hardware and creating multiple virtualized hardware environments. Those are our VMs. Each VM gets its own hardware configuration, and it can run a separate copy of an operating system. As we talked about, I believe in Lesson 1, if you buy a copy of Windows Server 2016 Standard, you get a license to install one physical copy of that server. But you're also allowed to use that license to run two virtualized copies. You run those as if they were standalone computers. Now, VMM is usually associated with older technology. Don't confuse it with the SC VMM, the System Center Virtual Machine Manager. That's something totally different. Now, to be able to run several virtual machines on a single computer, first off, you need to make sure you've got sufficient processing power. You got to make sure you got enough memory to handle a load. Granted, Most servers are often sit idle for hours on end. This allows virtualization to utilize the server's hardware more efficiently. Now, to keep each server secure and reliable, each server is placed in its own logical partition that isolates the processing and memory. And now that partition, it's a logical unit of storage in which the operating systems are hosted. Don't confuse this with a disk partition or a volume that divides storage area. This is something different. Each virtual machine accesses the hypervisor. This handles interrupts to the processor and redirects them to the respective partition. Now, almost guaranteed this will be a test question. The VM bus. What is the VM bus? It's a high-speed memory bus, and it was developed specifically for Hyper-V. Your I/O traffic between the physical host and the virtual machine and request for physical access to physical devices occurs over the VM bus. Make sure you remember that. Now, we use Hyper-V Manager, and here's Hyper-V Manager on your screen. We've seen that many times. We use that, and in this example, in our last lab, we saw how we create new virtual machines, and we can define the hardware resources that the system should allocate to them. Depending on the physical hardware available to the computer and the limitations of the guest operating system, you can specify the number of processors, the amount of memory, all of these things, what you're going to allocate to a virtual machine that it can use. You can install virtual network adapters, and notice that's plural. You can have multiple adapters. And you can create virtual disks using a variety of technologies. We can also connect to a SAN, a storage area network, for our storage. In our last lab, we saw how on the fly, while our virtual machine was running, we created an additional hard disk and attached it, and then installed all of our applications and our Windows deployment services in that disk without ever shutting down the virtual machine. Where does it store these files that make up the virtual machines? Well, Hyper-V stores those files that make the VMs in the folders you specify on the default stores page when we're installing. So where does that go? Let's take a look here. If we go in here and we go into Hyper-V settings, well, here's the location of where our hard disks are going to be stored. Here's the location for our virtual machines. There's two locations right there. If we look into our actual hard drive, and let me open this up. Just a moment. And we come over here. We can go into Hyper-V. There's our virtual disks. Here are our virtual machines and all their associated files. And then additionally, on the fly, it creates a snapshots folder. And this is where the snapshots, the checkpoints for the VMs will be stored. That configuration file, it's an XML file. We looked at XML previously in our lab for a installation file. Well, it's a virtual machine configuration. It contains all that information, including all the settings for the virtual machine. We just saw where we store one or more virtual hard disks, and keep in mind they can be VHD or VHDX files. Now the VHDX can be much larger. And that's where we store the guest operating system, our applications and data. That represents the hard drive of the VM. We can also have a save state. When we shut down this computer, what happens to the virtual machines that are running? For instance, right now the Lund DC1 is running, and I've got the Win 2016 core running. What happens is they don't crash, they don't stop. No, they go into what's called a saved state, that .vsv file that we see listed right here. Hyper-V saves the state of your running virtual machines, so the next time you turn on the computer, they restart just as if they had never stopped. No loss in functionality. Just as with each new release of Windows Server, Hyper-V has in turn been upgraded as well with different new features and functionality. There's host resource protection, the manager improvements, nested virtualization. You know, nested virtualization, we'll talk about that here in a little bit. The ability to run Hyper-V, a virtualized infrastructure, within your virtualized infrastructure. What was that? The DiCaprio movie, a dream within a dream. Well, kind of doing the same thing. Don't do this in production, but allows you to test things in a virtualized environment. We can do cluster upgrades. We'll take a look at PowerShell Direct. Some really, really cool features that have been added over the years. So, what seems to be the reoccurring theme as we go through each one of these exercises where we're talking about how we're going to do something? Planning. You need to determine your hardware and compatibility requirements. You're not just going to install the roll and go, oh, wait a minute, we need to buy more memory. Oh, wait a minute, the processor on this wasn't fast enough. The hard drives aren't big enough. They're not fast enough. No, you need to determine, does your hardware meet your requirements right out of the box? So understand, and almost guaranteed it'll be a test question, to run Hyper-V, you got to have a 64-bit processor, but more than that, it has to be a 64-bit processor that incorporates SLAT technology. That's second level address translation. You got to have a minimum of 4 gigs of memory. Just the base system is going to use probably 2 gig. You can't run any VMs if you don't have any extra memory. Your main board must support the Intel VT, that's Intel Virtualization Technology, or if it's an AMD board, AMD Virtualization, that's AMD-V. They must be enabled. You also need to have hardware enforced DEP, data execution prevention. It must be enabled. Your modern processors developed by Intel and AMD, they've got built-in capabilities that are used to simulate virtual machines. That's our SLAT, the second level address translation. It's also known as nested paging. You may see that question. It reduces overhead that's needed to map those virtual to physical addresses. So you can run more virtual machines at the same time. That's what this does. DEP, data execution prevention. It's a system level memory protection feature. You've had it in your copies of Windows for years and you never even knew it. Where do you find that? Let's take a quick look. If we go to our system under System and Security and Control Panel, and we go to Advanced System Settings, if you select Advanced, which is what comes up, and you click on Settings, right here under Performance, right there it is, Data Execution Prevention. And it is on for essential Windows programs and services only. That's by default, right out of the box. Now, you can select it for all programs and services, but then you got to specify those that may not behave nicely with it. But right out of the box, Windows does support it. What else? In addition to those processor and motherboard settings that need to be there to support virtualization, you also need to make sure you've got the resources to run the virtual machines. Understand that your Hyper-V host, it can support up to 512 logical processors and 2048 virtual processors. It can support up to 24 terabytes of memory. And you can run over 1,000 virtual machines per server. A lot of capabilities. We can install the role using the install-Windows feature commandlet. So we can do this through PowerShell. We can also do it through our server manager. and it's right there in the middle of the screen. You select it, and we add the features. Now, if you do it from the command line from PowerShell, you would do install Windows feature dash the name of the feature, which is hyper dash V, and then another space. This is not 2 lines. This is actually 1 full line. Make sure you understand that. So install dash Windows feature space dash name space hyper dash V, another space dash include management tools, another space, and then dash restart. So what that does is it installs the role, it installs the management tools, and then automatically restarts the computer so that it's enabled. That's those management tools. Well, do you have to have Hyper-V installed to have the management tools? No, let's take a look here. This is the jump box that I use to do remote management for my former employer, who I still do contract work. Here is Hyper-V Manager. This is running on a copy of Windows 8, and it allows me to access the servers with their Hyper-V infrastructure. Now that we can go ahead, we can take a look here. These are all replicas that are being replicated from the file 2. If we look here, there's those, for example, app server. Come back to file 3. A replica of it's being created and stored here by Veeam replication. It does it automatically. And you can see it happens every day, every evening, on schedule. So were this file 2 to crash and not have these running virtual machines available, they could be turned on this one. Automatic replicas. But I'm sitting on a copy of Windows 8 managing Windows Server 2012 R2 and Windows Server 2016 Hyper-Vs. That's those tools. And then here you can also install it on your copy of Windows 10. That's how I have access to it here on my physical machine. Now, what if we want to do remote management? Well, we just saw that. Using that console, you simply right click Hyper-V Manager and say connect to server. You type in the name of the server that's running Hyper-V and it connects. That's how these are on that screen. Now you can upgrade from earlier versions of Hyper-V. So if you've got a server running 2012 R2, you could install the Windows Server 2016 disk and double click the setup program to start the upgrade. Understand though, an online upgrade is the most complicated upgrade. Remember that. Make sure if you're going to do this that you have a current backup of all the hosts and VMs that you're going to be doing this to. So if you're going to upgrade one Hyper-V server, that's your host, that's your hypervisor, make sure you have a complete backup of that unit and that you've backed up all the VMs. If you're doing this in a cluster where you've got multiple servers running Hyper-V in a cluster, move those VMs to the other cluster nodes. Simplifies your upgrade. Now, when you create a virtual machine, the configuration file is going to be specific to the Hyper-V version that's installed on the host system. Here in Table 7-1, we can see those various features and related features that have been added with newer versions of the VM configuration. Understand that if you simply move a VM, say from Windows Server 2012 R2 to Windows Server 2016, that you will not get those new features automatically. So now if that VM is going to stay on that newer host, you may want to consider upgrading the configuration file. And how do you do that? You simply right click on the VM and you will have an option to upgrade the configuration version. Understand though that it's a one-way upgrade. You will not be able to revert back to an earlier version without restoring from backup or creating a virtual machine and pointing to the virtual disk. Okay? Keep in mind, this is just a configuration file. If something goes wrong with that, as long as the hard disk file is fine and you know what the settings were, which are pretty common, you simply create a new virtual machine configuration and attach the hard drive to it. And specify the number of processors, the amount of RAM, the network interfaces, how it's connected, and away you go. Now, what's PowerShell Direct? Well, we know what PowerShell is, and we should understand that we can use PowerShell. PowerShell is a lot more in command prompt. We already have seen that. With PowerShell, we can connect to other systems. We can create remote sessions to run PowerShell commandlets on a remote host. A lot of flexibility there. Now, with the addition of Windows Server 2016 and Windows 10, we now have PowerShell Direct. This allows us to connect to a virtual machine via the Hyper-V host. The VM doesn't even have to have a network connection. To use PowerShell Direct, make sure you understand those bullet points there. It's got to be Windows Server 2016 or Windows 10. The host has to be that. The guest has to be that. You got to be running Windows PowerShell as administrator. You got to provide credentials to authenticate. You need to make sure that that configuration version's been updated. The virtual machine must be running locally on that host. And of course, it's got to be turned on. So, how do you do that? Let's take a look. Got PowerShell right here. We can simply enter the command. Enter PSS session. And we give it a VM name. And that VM name is Win 2016 Core. And we're going to press enter. There's our prompt. Well, the configured account that's on it is a datum administrator. And our password to access it. And there we are. And we can see that we're remote connected. See the name of the server right there that we're connected remotely to. Let's say we are preparing to add a feature, but we want to get an inventory of what features are installed on this server first. So let's do a get Windows feature. Just that simple. And there they are. Every feature that's got an X, and every role that's got an X, has already been installed on this system. This is Windows Core, so it's running a pretty slim set of roles and features, right? But right there they are. That quickly. And it's what's on that remote host. If we're done connecting to it, we can simply type exit and we're disconnected. That is how you remotely manage Hyper-V hosts. Now, at the beginning we talked about nested virtualization. This is new with 2016. It allows a guest VM, just like we were looking at, to become a VM host and run guest operating systems. So it allows you to run a guest virtual machine in a guest virtual machine. Like I said, don't do this in production. It's not what it's made for. To enable it, it's got to be Windows Server 2016 or Windows 10. You got to have at least 4 gigabytes of memory or more allocated to that virtual machine, and you got to turn off dynamic memory. Let me repeat that. You have to turn off dynamic memory. That VM's got to be the same build as the host. We got to enable the virtualization extensions of the virtual CPU. And here's the command to do that. And here again, this is all one line. It's not two lines of, it's not two different commands. It's one line, one string that you're going to run. And that's set-VM processor space dash VM name space the name of the virtual machine in quotes, another space, dash expose virtualization extensions, all one string, another space, and then $true. That means on, yes. If you were done testing this and you wanted to turn it off, you would do the exact same command line except with the $ false at the end. And it may go without saying, but I'll say it anyhow. You can't run that PowerShell command if the VM's running. The VM must be shut down. And once you do that, once you enable that virtualized extension of the vCPU to do our nested virtualization, the following right here, virtual base security, device guard, those features are going to get disabled. You won't be able to do any checkpoints. It's not going to be eligible for live migration, any of that stuff. All right. The state's not going to set saved when you shut it down. When you shut it down, it's just going to crash. So you'd have to shut that machine down before you shut down your physical machine. Now, for guest virtual machines to communicate on the external network, you must enable MAC spoofing for the VM that's hosting Hyper-V. If you don't enable MAC spoofing, network packets from guest virtual machines are not recognized as legitimate and are blocked. Alright? So you can do this. You go in here and you go to your advanced features under your network adapter. Do you see these settings right here? You click on Enable MAC address spoofing. Now, I've never had to do that personally. I'm not sure what they're talking about here, to be quite honest, because I have virtual machines that communicate externally all the time. And they work. Now, do we always want to be the person that has to manage Hyper-V? You may be in an environment where many people need to be able to manage Hyper-V. They all have different responsibilities, but they have to be able to manage Hyper-V. Well, you can use this PowerShell command, the grant-vm connect access. This allows you to grant permissions to connect to a virtual machine. All right? That allows a connection to a virtual machine. If you want to give people the opportunity to manage Hyper-V Manager and be a Hyper-V administrator, this is where you do that. You would come up to your computer management, go into Hyper-V administrators, and you would add them to that group. Just as you see on the screen right there. Not as long a lesson as many of them, but in this lesson you learned that by using VM technology we can run many operating systems concurrently on a single physical machine. This allows us to separate our services while keeping cost at a minimum. Think about it. If you needed to have a separate DHCP server and a domain controller and a file server and a this server and a that server, and all of a sudden you had to buy 5, 8, 10 physical servers, it gets expensive. You've got hardware to worry about. Is that what happens when that power supply fails? What happens when this fails? What happens when they get old? The power requirements, the cooling requirements for the server room, the humidity, the climate control requirements. Or we could turn around and buy 3 servers that maybe have a little bit better capabilities. Run them in a cluster and build a Hyper-V infrastructure within that hosts those 10 virtualized servers. So instead of having 10 physical servers that you've got to maintain, you've got 3 physical servers to maintain and then manage those 10 virtualized servers. Hyper-V is a hardware virtualization server role. It enables you to create and manage virtual machines, that's VMs. And we use a virtual switch, just as if we would have a physical switch to connect our network connections to our physical machines. We use virtual switches. By using this hardware virtualization, you can subdivide a single physical computer, and it can get subdivided into and allocated to multiple virtual machines. Typically, the physical machine that's running Hyper-V, we call that the host. Wherever the virtual machines are running, they run on the host. That's your hypervisor. Hyper-V is managed using the Hyper-V Manager, or you could use Windows PowerShell with the Hyper-V module for Windows PowerShell. Now, typically, if you install Hyper-V from your GUI through Server Manager, you're going to include the management features. If you do it from the command line, you need to make sure that you run the command to add those management features. We also looked at how we can use PowerShell to remotely connect to sessions to a server and be able to connect to that using PowerShell Direct, not even having to have a network connection. PowerShell on its own can run remote sessions, but it needs to run across a network. PowerShell Direct on that Hyper-V host doesn't need to have those VMs with a network connection. And then finally, we briefly talked about nested virtualization, whereas we're running a dream within a dream. No, we're running a guest VM within a guest VM. So you have a Hyper-V host that's running a guest VM, and that guest VM becomes a Hyper-V host, and it in turn can run a guest operating system. I hope you enjoyed Lesson 7 in 70-740. Thank you very much.